Good morning and welcome. Hopefully you guys had a good weekend. How is everybody? How are we doing this morning? Besides being tired. I beat you to it, Tyler. Cold? Get some sweatpants. Get a blanket. Oh, Kate, if you want to double check, I did just put all the tests into Skyward. So there's a significant curve on it. I also still have to put in all the other grades into Skyward. I'm so sorry, Sadie. But yeah, no, if you check you can check Skyward right now. The tests are in. I haven't put the other grades in, but I did want to get the test in so that you guys could see that I'm curving it a lot. So yeah, double check that. I don't know anything about that, Valen. Probably, is he? You would catch fire and burn before so. If you did it in like a non-oxygenated environment, yeah, but I don't know what that is. Oh, you guys have a digital citizenship test today? I guess that would maybe be for like English or something. I don't know. Oh, okay, here we go. Today is the day of digital citizenship. I don't know what that means. I have like a billion emails. I need to check all that. Well, yeah, because I literally just did it this morning, so I haven't had a chance to talk to Weaver about it. There's this thing called the weekend where I didn't work because it was the weekend. So it'll get updated today and tomorrow, Drake. Don't worry about it. Yeah, we'll get it updated. You got to remember, things are going to take a little more time now because everybody's working from home, and so in order to get stuff in and updated and communicated, it takes a little bit longer. So things will take a day or two to get into the gradebook. Speaking of all of your other assignments, I'm going to get in tomorrow. That's why I'm not streaming on Tuesdays, is so I actually have time to update your gradebooks. So tomorrow, I expect a lot of assignments to go into the gradebook tomorrow. All right, Zach. Let's keep that. Okay. Urgent message. Oh, you can't go to Brighton anymore. Okay. Okay. Yay, Cinnamon and Earls Drake. Those be fantastic. Ellie, do your English homework. And yeah, I decided to change the orbs to valence electrons. I'm going to add some more things to it. I'm going to do a lot of stuff. I've got sub badges now. See, look. Check this badge. So, and it's basically like a little flask that gets more and more reactive the longer you stayed sub. Ooh, it's so fancy. I'm working on emotes. I'll get emotes too. But I am sorry, Trinity, that your math class is difficult. Wait, is that Clark for math or Clark for English? There's two Clarks. I did curve it, Eliza. Go ahead and check. You can check your grades on Skyward. Yeah. I went ahead and curved it and put them in on Skyward so you guys can see those. Oh, Clark for English. Yeah. I think she's giving you like a bunch of packets and stuff, isn't she? I don't know. The curve is interesting. Basically, it was kind of like a flat curve. Yeah. More or less, your score just got boosted. But there were a couple people that ended up with over 100%. So I think a perfect score would have been like 110% or something. But yeah, no, I'll put in all the other grades and stuff. Yep, no problem, Meredith. You did really well, by the way, Meredith. Good job. Yeah, so I was going to take the next couple minutes and just talk about the test. We have a couple people that forgot to take it, so I'm going to be making phone calls to their homes today just to see what's going on with them. Not very many, only like two or three, so it's not going to be that bad. We are doing class Monday, Wednesday, Friday. So here, let me pull the calendar back. Right. So on the calendar we have Monday, Wednesday, Friday streams, and then you have. Well, Izzy, it wouldn't have been good if you forgot the test. I would have been mad about it. But yeah, no. So Monday, Wednesday, Friday, Monday, Wednesday. I can't speak. Monday, Wednesday, Friday for class, Grayson, and then you have a homework due every week on Thursday, and then sorry, Drake. That's what I'm doing. AP. So AP is from 10 to 11. Nice, Cooper. I was wondering why you weren't early today. That's really late, Drake. I want to. I like getting started in the early. 8:30 is not that bad. If we were still in school, you would have class at like 7:45. So I'm giving you 45 minutes. 12 to 13. Yes. Yes. Military time. Sadie, that's true. You could also go back and watch the videos, but if you watch the videos, you miss out on the opportunity to ask like questions with an immediate response. So, um, that's the unfortunate thing. Yeah, then you can't troll the chat, right? Goodness. I forget how different I look when I shave. I have a lot rounder of a face. The Gucci interaction, exactly, Valen. And you miss me mispronouncing Valen's name all the day. I'm tired too. I'm tired too. Oh, over the weekend, I know I'm really late to this, but my wife and I watch Knives Out. It was a really good movie. Yeah, Ellie started that, by the way. We are more or less continuing the notes, Cooper. We're kind of just doing more. We're gonna talk more about just reactions in general. So, let me see if I can find my old notes. Yeah. So we're gonna do like a Roman numeral 2. So Roman numeral 1, if you remember from Friday, was balancing word equations, right? Valen, don't make me time you out. Okay, so balancing word equations, right? And then, so what we're going to do now is we're going to talk about 5 types of reactions in general. So this is going to be Roman numeral 2 in your notes. Okay, so we have 5 types of reactions. And this is the intro. So what we're going to do for the next couple weeks is we're going to do basically a whole lot of just reactions and writing reactions and predicting the products of reactions. And so this is going to be our first step into predicting what a reaction produces, right? So normally up to this point, you've always been given the reaction. You've always been told what it produces. But we're going to be able to we're now going to be able to understand certain kinds of reactions to the point that we can actually predict what they're going to produce, which is a pretty cool chemistry skill, in my opinion. Okay, so we've got 5 types of reactions. We're going to go through them. Now, one of them you actually already know. Kate, you mean the previous test or the current test? No, Liza, you'll be fine. This is gonna be this is gonna be a whole lot easier than it would be if we were in class, I promise. I don't know, Kate. Probably more like 50-50, I think, as opposed to the 70-30 or 60-40 they used to be. So it'll be. We'll worry about grades. We'll figure out grades. So nice, Drake. I know in class is a whole lot better, which is why I'm trying to make it a little easier. Yeah, Hunter, that was posted last week. We talked about it Friday, and I uploaded it to Canvas. It's due Thursday night. Grayson, you're fine. Don't even. You did great on the test. All right. So first type of reaction, again, this is one we've already talked about. We talked about this last time. Combustion. That's okay. All right, so combustion. So combustion reactions, right, as we've talked about before, are some carbon, hydrogen, oxygen compound, right? X, Y, and Z are variables. They could be 1, 2, 3, whatever, okay? Plus oxygen gas makes carbon dioxide and water. Okay. So this is our general combustion reaction, right? Any sort of carbon, hydrogen, oxygen compound plus oxygen making carbon dioxide and water. We've been talking about combustion for a really long time. We've been able to predict the products of combustion for a while. So this one you guys already know. I just wanted to kind of re-emphasize it here. Okay, a good example. I don't know. What do we want to burn? We can take something simple. Hunter. So funny. Hey, Drake, Hunter beat you to it. So let's do just a simple methane, CH4. Right, so the combustion of methane produces carbon dioxide and water. Okay, so in terms of balancing, we see we have one carbon, 4 hydrogens. There's only a 2 here, so I'm going to put a 2 as the coefficient. Okay, 2 oxygens, 2 oxygens. So I have a total of 4 oxygens on this side, which means I need a 2 here. Okay. All right, so there is our combustion reaction. There's not really a whole lot to talk about with combustion besides it's just a fuel plus oxygen making carbon dioxide and water. Anytime you burn something, almost always plus oxygen, carbon dioxide, and water. Okay, so I guess some keywords would be things like burn or combusts. Etc. Okay, cool. So there is our combustion reaction. First of our 5, simple, easy. We've already talked about it. Okay. Yeah. So some of the basically what you'll see. So an example of a problem like this that we're going to work towards next week would be more something like. Methanol burns, and you would have to write the reaction. Okay, Technically Cooper, yeah, but not for our purposes. There are technically you could have like nitrogens here and produce nitrogen on the other side, but that's beyond what we're going to be doing. So every combustion that we're going to do is either carbon, hydrogen, and oxygen, or just carbon, hydrogen plus oxygen making carbon dioxide and water. Yeah, so this second equation, CH4, is methane. Nice. Okay. Yeah, well, so we do have a lot of carbon, hydrogen, and oxygen compounds in us. People are a lot of carbon, hydrogen, and oxygen. We, of course, have some other elements, but a pretty big majority of us are carbon, hydrogen, and oxygen. So all the ones we do will come out. Yeah, if it's a combustion, CO2 and water. Yep. Yeah, it's pretty simple, pretty easy to predict. Okay, let's do next one. Letter B. Synthesis. Oh, if I could spell. Okay, so synthesis. So synthesis is kind of what it sounds like. Okay, when you hear synthesis, you should think of things coming together. And so our synthesis reaction in general is when we have one compound plus another compound, or sorry, one element plus another element to make a compound. Okay. So we can just combine two elements. Melt something that burns, yes, you just have to do it without oxygen. Because if you don't have any oxygen, then you can't have combustion. And then burn something that melts, sometimes it depends on the thing that's melting, because you'd have to have like a really high oxygen environment. But even then, there are things that don't burn, like water, right? Water doesn't burn. All right. So let's talk about synthesis. So synthesis is when you have two things come together to make one thing. Okay. So let's just imagine, let's do a complicated one, I guess. So what you might see in words is you might see something like, we'll just say sodium reacts with sulfur. Right? You can tell us what kind of equation we're balancing. No, well, kind of. You'll be able to predict based on what you're reacting. Oh, yeah, sure. Xander. Okay, so sodium reacts with sulfur, right? So how would we write the reaction between sodium reacting with sulfur? Well, sodium is a metal, right? Na, solid. Okay, reacting with sulfur. So reacts with, we draw plus. Sulfur, sulfur's just S. It's not one of the diatomic elements. Okay, so it's also going to be solid. If we look on the periodic table, it's solid. And then we're going to produce, well, it's a synthesis reaction, right? So A plus B makes AB. So we're going to make sodium sulfide, okay? So sodium sulfide should be, the combination of sodium and sulfide, right? And it would be nice if it was just as simple as NaS. But because this is an ionic compound, we need to make sure the charges balance out, right? And so if we look at the periodic table, sodium is in the first column. So when it reacts, it forms a +1. And sulfur is in the third to last column. So when it reacts, it forms a -2. And so our formula between sodium sulfide is actually Na2S. And ionic compounds are almost always going to be solid. Okay. Yeah, no, not thiosodium. Although you could maybe think of it as thiosodium, but the proper name would be sodium sulfide. So this is kind of how you do a synthesis reaction, right? Okay, yeah, so we're not done with balancing, of course. Yeah, we need a 2 back over here. Okay. Everyone's losing their minds over the sodium coefficient. So combustion doesn't necessarily separate, Tyler. Combustion, I guess in a sense it does, because it breaks down the fuel, but it turns the fuel into carbon dioxide and water. So it's more of like a transformation than I would say it's like a separation. Okay, because the next reaction we're going to do is a separation. All right, so synthesis. A plus B makes AB. Sodium reacts with sulfur. Sodium and sulfur. So you'll always have 2 things combining to make a final product. No. I very much appreciate it, because that means I know that you guys are engaged. Combustion's always exo. Vinx 8000. Combustion's always exo. All right, but this kind of reaction, right, if we're not going to be talking about endo-exo very much anymore, but if we were, we would predict that this reaction would be exothermic as well, because we're forming a bond. All right, so that is synthesis. So let's move on to letter C. So letter C is going to be decomposition. Combustion. Hey. Mr. Weaver in the chat. Shout out to Weaver in the chat. It's not that loud, Olivia. All right, so yeah, it's exactly, Zach. It's the opposite of synthesis. This is where you have AB breaking down into A plus B. I don't actually know, Cooper. I think decompose has been around a lot longer than decomposition reactions would be my bet. But you'd have to look up the. I'm not a linguist. Thanks, Tiara. Oh my gosh. AB breaks down to A plus B. So with decomposition, it's going to often require heat, right? Because decomposition, we have to break bonds. They're going to be endothermic. Yeah, everyone got the digital footprint thing to do, Xander. Okay. So an example of a decomposition reaction would be, let's see. I don't know if you have to do it. I think it's just because today is like Digital Citizenship Day. And because we're starting like this online learning thing. Yeah, I don't know. It's not for my class, so I don't care. All right, so let's think. We could talk about like water, right? So if you take water and you put a strong enough electrical current in it, you can get it to break down into hydrogen gas and oxygen gas. Okay, sorry, you guys said a lot of stuff in the chat here. Oh, Sherwood asked all students to do it. Okay. Okay. All right, so water breaks down into hydrogen and oxygen. Now, of course, this equation isn't balanced. Yep, got to have the, thanks, Dr. Quantum. We got to have our coefficients of 2 and 2, right, to get the hydrogens to balance. We need the 2 for the oxygen. Okay, there we go. So 2 in front of the water, 2 in front of the hydrogen, 1 in front of the oxygen. That makes 4 hydrogens on the left, 2 oxygens, 2 oxygens. What's the sign next to? Oh, that's an L. Sorry, it's kind of like a cursive L. So, Grayson, everybody's talking about the digital citizenship thing. I guess there's a link on Canvas. Do it, I guess. I don't know. School will for sure be back by next year. But, yeah, well, Drake, it's hard to make anything required with you guys all being at home. Yeah, there you go, Sadie. Sadie's got it. Okay. Cool. So in general, decomposition, you take a single compound and you break it down into its elements, often requires heat or electricity. Now, we'll get into some more special cases of this a little bit later. Okay. So, letter D. Some of you do, Cooper. Some people don't. All right. So we've talked about synthesis. We've talked about decomposition. We're going to talk next about single replacement. I don't know about that one, Zach. Single replacement. So, for single replacement reactions, single replacement is what it sounds like. You take a compound, AB, you add a third element like C, and that third element is going to replace either A or B. No, Lauren, it'll all count for my class at least. I'm going to put everything in. I'm sorry you have an F in Spanish, Johnny. Yeah, no, we'll figure all the grade stuff out. We'll be all right. Yeah. Oh, that sucks for math. I'm sorry, Lauren. But I can't speak for other teachers. I can only speak for my class. All right, so AB plus C. Now, depending on if C is a metal or a non-metal, it will replace either A or B, right? So if C is a metal, it'll replace A. If it's non-metal, it'll replace B, and we'll do both. Okay, so let's imagine it's a non-metal first. So if C is a non-metal, then we're going to get AC plus B. This one would be kind of hard to predict if it was endo or exothermic, Enya. This one would depend on a lot of things. All right, so let's imagine. So let's see. We'll say metals replace metals, and nonmetals replace nonmetals. Oh, you have to look at phases. For the one that was like that on the test, it matters about the phases. I think it went from like solid to gas or something, so it was endothermic. Okay, so let's do 2 examples. We'll do one example of like, let's just do, I don't know, copper sulfate plus magnesium. Tiara, people did pretty well on the test. I mean, some people didn't do great, but like I said, as a whole, everyone did all right. The average after I curved it was like a 90%. So, I mean, would I have wanted you guys to do better? Probably. Would have you done better? Would you have done better if we were still in school? Probably. But Whatever. It's whatever. I'm sorry, LolXD. All right, so copper sulfate for magnesium. So if we follow the format, right, the magnesium is going to replace the copper. So what are the products of this reaction going to be? Yeah, Lauren. Yeah, we're going to do 2 examples and show you. Yeah, it's magnesium sulfate and copper. Yeah, so we'd get magnesium sulfate, aqueous, plus copper, solid. Sorry, I ran out of room. Right, so it's the idea that the magnesium replaces the copper. So it comes in and replaces it. Yes, you can say daft. It's fine. Okay. No, it's a solid. So metals are going to be solids, right? So they're going to follow their normal phase on the periodic table. So solids. All right, let's do another example. This equation is actually already balanced. It's just 1, 1, 1, 1, 1, 1, 1. So let's do an example of if we had a non-metal. So for example, let's take like, I don't know. Sure, we'll do like, yeah, we'll do, how do we want to do this? Let's do, no, not magnesium. We'll do calcium chloride. Oh, this is going to be 1 to 1 again. Oh, well. We'll do calcium chloride. We'll react it with fluorine gas. Okay. The phases aren't super important right now. All right, so calcium chloride aqueous reacting with fluorine gas. So because fluorine is a non-metal, which element is it going to replace? Yeah, the phases don't change, Lauren. Yeah, so we're going to get calcium fluoride, but you got to be careful, Icy Snow, whoever that is. It's going to be CaF2. Because positive 2, negative 1. I should have picked a different one, but that's okay. So this one will be aqueous, and then we'll say the chlorine is a gas. All right, so again, metals, magnesium, replace metals, the copper, and non-metals, the fluorine, will replace non-metals, the chlorine. So, you know, AB plus C, right? In this case, it replaces A, and in this case, it replaces B, because depending on if it's a metal or a non-metal. All right, so there's our single replacement reactions. We'll talk we'll give a little more detail about this later, probably Friday. So don't worry about kind of the nuances about it for now. Just remember that metals replace metals, non-metals replace non-metals. Yeah, Trinity, we go on walks like every day as a family, just around our block, just so we can get out of the house. Sorry, I'm moving around a lot. Okay, our fifth and final type of reaction is double replacement. Yeah. So letter E, double replacement. So as Simon is predicting, yeah, we still have like 25 minutes. Chill out. Skating's fun. Claire's much better. We got her some antibiotics for her. I think she had an ear infection, so she's much happier now. All right, double replacement. That's an A. Sorry. So double replacement reaction. In a double replacement reaction, you have AB plus CD making. Now you got to be careful on this. The first elements are going to switch. So A and C are going to switch. And so we're going to get CB plus AD. Oh, yeah, trust me, Cooper. I know how antibiotics work. We'll go through the whole route. We still have a couple more days. Yeah, no, I know how antibiotics work. All right. So, let's do an example. Well, actually, let's make a statement first. It often forms solids, which we call precipitates. All right, so sometimes double replacement reactions are called precipitation reactions. Can I ever switch to AC plus BD? No, Johnny, and the reason why is that these are metals, right? So these are both positively charged. A and C are positively charged. B and D are negatively charged. So you're not going to have two positives come together or two negatives come together. So you're always going to have positive with negative, and so you can think about the positive switching places or the negative switching places. They don't, Drake. Okay, so let's do an example. Let's make I don't know. Oh, this one will be fun. We'll do a complicated one for like equations and balancing. So we'll do calcium nitrate. Do I want to stick with calcium? No, let's do like sodium nitrate. No, calcium nitrate. So calcium nitrate, CaNO3, 2, aqueous, plus sodium phosphate, Na3, PO4, aqueous. Okay. Yeah, they let you highlight your message. I'm gonna add some more stuff to it. I'm still kind of customizing that. Yeah, Lauren. So it always matters. You should always write the positive element first, and then the negative element second, right? So it's always should be metal then non-metal. Oh, you were trying to make a poem, Zach. That was terrible English. Okay. Yeah, the cations come first, Mr. Weaver. Yeah, it's always positive element and then negative. All right, so let me reorganize my notes here so I can actually see this. Okay. So, so what's going to happen is our calcium and our sodium are going to swap. Okay, so we're going to get sodium nitrate as one of our things. I'm going to shift it down here so I have more room. So one of our products is sodium nitrate. and I'm going to tell you right now, this one's aqueous. We're going to talk about how you can predict phases, but we're going to do that later. The other product is going to be calcium phosphate, and that's going to be our solid. But this is not the right formula for calcium phosphate. No, there were two problems that were miskeyed, so I fixed those. Yeah, Lauren, it is Na3, and the reason why is let's first talk about, well, it's not Na3, but let's talk about it. Okay, so in our first case, we just want the ions. We don't care how many there are in these formulas, because if you remember, these numbers are just to balance the charges. Okay, and so we're not worried about balancing the charges until we write the new formulas. Okay, so in this new formula, sodium is +1, nitrate is -1, and so +1, -1, it just stays together. It's just NaNO3. Okay, but on this compound, what's the charge of calcium and what's the charge of phosphate? So calcium's +2, right? What's phosphate? Okay, Anya, hold on. We're going to balance the equation later. We got to do this in a very precise steps or we're going to throw it off. So phosphate is -3. Okay, so if calcium is +2 and phosphate is -3, what's the formula? It should be Ca3PO4 2. Yeah. So Ca3PO4 2. Because that makes, if this is +2 and there's 3 of them, that makes +6, right? And if this is -3 and there's 2 of them, that makes -6. Okay. So now that we have the formulas written correctly, now we go back and balance the equation. Now we care that there are 3 sodiums here. When we're writing this formula, we do not care that there are 3 sodiums. This one's solid, Lauren, because this one's going to be our precipitate. Now, you wouldn't be able to predict that yet. We're going to talk about how to predict that next week. Okay. All right. Yeah, we're going to talk about why we know that this one's the solid precipitate next week. So hold off on that. For now, I'm just telling you calcium phosphate solid. All right, so now we got to balance it. So if I look at this, I see, let's see, I got 3 sodiums. I'm going to start with the calciums. 3 calciums over here. So you'll be told in the problem what the phase is. So on the homework assignment you guys have that's due Thursday night, you do not have to write phases. For the assignment due next Thursday, well, actually next week's spring break, the following week, we'll talk about all that other stuff. So the one that's due in 2 weeks, that one you have to worry about phases, and we'll talk about how to do that before then. So for the one that's due Thursday, you don't have to worry about phases. All right, so back to balancing. 3 calciums here, so I'm going to start with a 3 in front of the calcium there. Now when I do that, how many nitrates are there? Yeah, next week is spring break. How many total nitrates? 6. And because there's 6, right, because it multiplies, right? So that means I need a 6 in front of my NaNO3 because it makes 6 nitrates. And now I've got 6 sodiums here and 3 sodiums there, so I need a 2. And notice by doing that, my phosphates evened out. 2 phosphates, 2 phosphates. So if we look, the total equation is balanced. 3 calciums, 6 nitrates, 6 nitrates, 6 sodiums, 2 phosphates, 2 phosphates. Okay. So balancing was a little bit more fun on this one, but the general idea is that your positive ions switch, and then when they switch, you write new formulas based on the charges. You don't carry over the fact that there's 2 nitrates here. You don't carry over the fact that there's 3 sodiums there. Those are there to balance the charges. So swap the ions, balance the charges. It now is balanced, Tiara, yes. Okay, let's recap. So, 5 types of reactions. Ellie's talking about movies. All right, 5 types of reactions. The first one's combustion, right? Carbon, hydrogen, oxygen plus oxygen makes CO2 and water. The second one we talked about was synthesis. 2 things coming together to make a single compound. Decomposition, you have a single compound breaking down into its elements. Right? Single replacement, a compound plus some new element. That new element replaces the other. And then double replacement. Our double replacement are first elements swap, positives switch places to give us the negatives. Okay, another way to help you remember these reactions, I have kind of an analogy, which is fun. Okay. Ellie, be careful on what recommendations you're telling people to watch if they're like super sketchy. All right, so let's talk about the way I remember. So from synthesis, the way I like to remember synthesis is if we have like a you can think this analogy is so sad because it doesn't work anymore because we're all quarantined, right? We should all be decomposing. We shouldn't have any synthesis going on. Okay. Pulp Fiction's not. I think Pulp Fiction's overrated, Cooper. I think it's overrated. Yeah, I know, Mr. Weaver. All right, so let's talk about synthesis. So when we talk about synthesis, in general, the analogy I like to use is we have a sophomore boy. It's going to represent our A, and our sophomore girl is going to represent B. Sophomore boy and sophomore girl, they meet under normal circumstances, and what happens? They form an inseparable bond. They get a relationship. They come together, and they become like the best ever. Okay, I know it's 2020, Drake, but we're going to do sophomore boy, sophomore girl, right? So our boys are our positive metals, like we've used in analogies before, and our girls are our negative non-metals, okay? And so the two come together, right? So they're so in love, okay? Nice, Ainsley. All right, so what happens in decomposition? If this is our inseparable couple, right? Inseparable couple, boy and girl, by the time they hit 5th period, what's happened? It's the breakup. It's the breakup. Yep, they break apart. They break up. Sad. Okay. But they get back together. It's high school, right? High school romances. You always get back together. They always do. Okay. Now, let's imagine they're back together. Sophomore boy, sophomore girl. Okay. But the single replacement tells another story. Single replacement tells another story. And the reason why they're sophomores, Tiara, is because letter C, in this case, is, well, at least with the way I've drawn the reaction, letter C is a junior girl. Junior girl. It's a junior. This junior girl has got her life together. She's yep, basically. Yep. And so what happens is a sophomore boy looks at sophomore girl and says, if this junior girl is showing interest in me, I'm going to be on the, simp, basically. The guy's a simp. So he has decided to join up with the junior girl because the junior girl's got a car. She can drive him around. She can take him places. She's got money. I'm so sorry, Ainsley. Classic love story. Classic love story. And of course, sophomore girl gets left alone. Okay. So that's our sad replacement. And it's because the C is more attractive. We're going to talk more about that later in the week. probably on Friday. But the reason why this reaction happens is because C is a more reactive element, and so it has to be a more reactive thing. Okay. Sorry, Drake. You're just not a simp. All right, now double replacement is a different story. Totally different couple. Okay, so here we've got this is a double date situation going on, right? So it's you and your buddy, right, going on a double blind date, right? You're going out with some girl and his friend, or her friend, right? Some girl and her friend. And so you're going on the date, and you're like, it's a double date, and you think, you know what, I like my friend's date more than my date, and he likes your date more than your date. Okay. And so what happens here is we get a double replacement, right? So they switch because one of these compounds is going to be a much stronger bond. And so our double date replacement at the end of the double date, this guy ends up getting her number and he ends up getting her number, and they just kind of do a switcheroo. Okay, sounds like BYU. All right, so that's just kind of how I like to remember it. I like to remember what's going on in times of like girls and boys and their relationships, and then you swap around and do all those things. Okay, so again, 5 types of reactions. It's definitely better than Twilight, Ellie. Actually, it's pretty much the same plot as Twilight, except she can't decide which boy she wants to be with. Anyway, okay, we are at the end of the stream. So combustion doesn't quite work with my analogy. All the other reactions work with an analogy, but not the combustion. So unfortunately, yeah, the analogy kind of fails when we talk about combustion. All right, that's it for today. Reminder, tomorrow I will be putting a whole lot of grades. I'll be grading a whole lot of things. I'll be adding a sub-alert. I'll be adding all kinds of stuff, Seth. I'm going to be working on that. If I don't get it done this week, next week during spring break, I'll get a ton of stuff. I'll up the channel quality a lot. Burn the boys. Okay. I think that's all I have to say. This girl is on fire. This girl is on fire. Oh, babies? Sure. Where's my phone? I don't have my phone. Maybe I'll go... Where? Oh, my phone's over there. We got some poggers in the chat. I was grabbing my phone so I could text my wife to let the kids come in. No, I'm fully clothed. It's fine. I am just wearing jeans, though. I'm not actually dressed up. My shirt is not tucked in. I'm just chilling. All right, so reminder, you have the word equations sign, or word equations worksheet to do on Canvas. That's your only assignment. It's due Thursday at midnight. I'm going to work on like how you're going to turn it in. I'm going to develop a quiz to do that tomorrow. So right now you can just do it. Yeah, this is a real tie. It's not a clip-on, I promise. It's a real tie. You don't have to print it out. You can just kind of reference it. If you want to print it out, Enya, you can. You just kind of have to... I would write them all out by hand, just in your notes or on a paper somewhere. If you want to print it out and write on the paper itself, you can do that too. So many simps in the chat. Stop bullying Cooper. This is actually less notes. It's about the same than we would have at school, Matthew. Wait, your older siblings dated, Cooper? No way. That's crazy. That's really funny. I didn't know you had an older sibling. I wonder if my wife got my text. It was delivered. She didn't get it. I'll just go tell her. Say hi. You have a banana. Can you show everybody your banana? Here, show them. Look, show everybody your banana.
Banana.
Hi, Gavin. Do you want to say hi too? Look in the camera. Can you say hi? Here, we'll turn it down. All right. We will be back on Wednesday. Yeah, say we'll be back on Wednesday. Here, Kevin, scoot in. Okay, say we'll be back Wednesday. Can you say Wednesday, Gavin?
Yeah.
Wednesday.
Wednesday.
Wednesday. Okay, say bye, everybody. Can you wave bye?
Yes.
Bye to the camera. Say wave. Bye-bye.
Bye-bye, Gamma.
Say bye-bye, everybody.
Bye-bye. Bye-bye.